Every data pipeline eventually hits the same wall. A PDF full of tables that nobody wants to retype. Bank statements, invoices, lab reports, financial filings. You could reach for an open source parser, but messy merged cells and scanned pages will break it fast. In this video, we'll treat table extraction as a decision. When does Azure AI Document Intelligence earn its place? Which of its models fits your documents? And how do you wire it up in Python? By the end, you'll have a clear framework and a working code path. Document intelligence isn't one thing. The core decision is between three paths. The pre-built layout model extracts tables, selection marks, and text structure from any document with no training. The pre-built document or invoice models add semantic field extraction on top. And custom extraction or classification models let you train on your own forms when layout alone isn't enough. For pure table extraction across varied documents, the layout model is almost always the right starting point. You only move up the ladder when you need named fields, not just a grid of cells. Before you pick, get honest about what drives the choice. First, do you just need the grid? Or do you need fields with meaning like total and invoice number? Second, document variability. Are layouts consistent enough to train on, or wildly different? Third, scanned versus digital, because optical character recognition quality decides everything downstream. Fourth, volume and cost, since you pay per page and prices differ by model. And fifth, latency tolerance, because synchronous calls and large batches behave very differently. Score your use case against these five and the model usually chooses itself. Here's the trade-off that trips people up. The layout model needs zero training, handles any document, and returns every table it finds with row and column spans. But it doesn't know that the second column is a price. It just gives you cells and bounding regions. A custom extraction model can return clean, named fields and tie repeating rows to a schema, but you have to label samples, retrain when forms change, and accept that it generalizes poorly to layouts it hasn't seen. Rule of thumb: start with layout, graduate to custom only when post-processing the grid becomes more work than labeling. Let's make it concrete. Install the Azure AI Document Intelligence package, then call the pre-built layout model. You pass the document bytes, poll the long-running operation, and read back the tables collection. Each table gives you row and column counts plus a flat list of cells, where every cell carries its row index, column index, and any spans. From there, you reshape cells into a two-dimensional array and you've got structured data. Notice it's an async operation under the hood. So for large batches, you'll fan these calls out rather than blocking on each one. In production, you rarely call the service from a laptop. A common pattern: documents land in Blob storage. An event grid trigger fires an Azure function. The function calls document intelligence, and the structured tables get written to Cosmos DB or a database for downstream querying. Keep your endpoint key in Key Vault, never in code. This decouples ingestion from processing, lets you retry failed pages, and scales horizontally as upload volume spikes. The same shape works with container apps if your processing needs more than a function's limits. A few hard-won notes. Merged and spanning cells are reported with rowSpan and columnSpan fields, so don't assume a clean grid. Check spans before you reshape. For scanned documents, confidence scores matter, and you should flag low confidence cells for human review rather than trusting them blindly. Orderless tables are where layout sometimes guesses wrong, so validate row counts against expectations. And remember, pricing is per page and varies by model and tier, with a free tier for testing. Always check the current Azure docs, because model versions, page limits, and prices change regularly. So here's the framework. Start with the pre-built layout model for any table extraction, because it needs no training and handles varied documents. Only move to pre-built field models when you need semantic fields, and only build a custom model when post-processing the raw grid costs more than labeling and retraining would. Score your use case on structure versus semantics, layout consistency, scan quality, cost, and latency. Your one concrete next step. Grab the Azure AI Document Intelligence package, point pre-built layout at a real sample PDF, and inspect the tables collection. You'll know within an hour whether you need anything more complex. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.